How are you, everybody who is watching this fantastic video? I'm very happy to have you, and I would like to take this opportunity to welcome you into this interesting program of learning fundamental of practical electronics engineering. My name is Mwl Olenjolai. I am a Tanzanian, and I thank God by His own grace to have given me a gift of loving teaching and also loving electronics engineering. Today, I'm going to teach you about the beauty of resistor, or a resistor are the passive electronics components, or a resistor are the very important electronics components that we use in designing and implementing different electronics prototypes and the products. So I have some local students who are actually doing ordinary diploma in electronics and telecommunication engineering at DIT, and also have some local students who are doing a bachelor degree in electronics and telecommunication engineering at the Resistor Institute of Technology. So again, remember, these are the contents we are offering through our online institution, polytechnics schools or polytechnics college, and or just institution. The first one is called the Online Bachelor Polytechnics of Tanzania, square bracket Olenjolai. And the second one is called Online Diploma Polytechnics of Tanzania, square bracket Olenjolai. So in order for you to be in touch with this program, it's just as simple. Make sure that right now, before you go further to the contents that we are going to discuss today, make sure that you click the buttons of subscribe in order for you to register yourself as a free registration. Another thing which I want to grasp in this introduction, in case you have any question along the learning process of the theory or the simulation or the practical, please don't hesitate to ask that questions in the chat or in the comment sections, and I or other teachers or other students who love electronics might give you the response of your question. So I think that you are ready, your mind is okay, and your hands are ready in order to do in practice. So if that's the case, our motto, remember, that it's called the mind and the hands. So we are teaching or we are training our mind about the right and correct information, and then our hands will implement about what we are thinking and what we are intending. So let me appreciate and let I, online students, and also online students, and I appreciate and acknowledge the presence of the local students in this class. How are you, student? How are you, student? Do you like electronics engineering? Okay, so you hear their voice. And are you ready for workshop 4.3? Yeah, so they are ready, and also for you online, I believe that you are ready. So let us go into the business. So the name of the module of the course is called the Fundamental of Practical Electronics Engineering. The name of our online institutions is called the Online Bachelor Polytechnics of Tanzania, square bracket Olenjolai, or online, and the other ones is called the Online Diploma Polytechnics of Tanzania, square bracket Olenjolai. We are in chapter 4. In case you missed the lecture or the workshop of the previous chapter, don't hesitate to yourself or just access in the playlist that we call it Fundamental Practical Electrical Engineering. You'll find the collections of all the previous workshop and video, which actually are more than 20. So this is workshop 4.3, which is titled as Measurements, Parameters of the Resistor. Say measurement, parameters of the resistor. Again, say measurements, parameters of resistor. So let us do the quick review of what you have covered in workshop, quick review of workshop or lecture 4.2. So in this lecture, we've learned mainly about 9 functions of what? Of a resistor. 9 functions of a resistor. The first one, it's common. We say that a resistor usually to limit or reduce what? Reduce the flow of what? The flow, or reduce the current flowing through the circuit. And we have done a demonstration with Joseph Jacob, right? We discussed about that one. So we say to limit a resistor, if you connect a high or a resistor of high resistance, can limit current. But if you connect just a resistor of low resistance, it can just reduce the amount of current flowing through the circuit. Are we together? The second function is what? We say that resistor may be used as in what? In voltage divider what? Voltage divider what? In voltage divider circuits. voltage divider what? Circuits. So in voltage divider circuits mean that we can use 2 or 3 or 4, especially 2 resistors. It depends. You can use 2 or 3 resistors or 4 resistors in different configuration. You arrange them in series or in parallel in order to do what? To divide the voltage. Are we together? Students, this workshop or this lecture is very important. So you have to pay attention, you have to listen, you have to ask a question, you have to concentrate. It's very important information because it's very helpful practical. Okay? So so voltage divider, but also a resistor can be used to bias what? To bias active components, and these active components these are transistors. It can be used to bias junction field defect transistor or bipolar junction transistor and field defect transistor. Are we together? The first function of a resistor, what did he say? So a resistor can be used to do what? To adjust. So a resistor, it can be used to adjust what? Adjust the signal what? Signal level. And I just taught you in case of the amplifier, where we call it just open loop gain and the closed loop gain. Are we together? Then the fifth function is what? Resistor can be used to do what? Pardon? So it means that a resistor can be used in measurement of what? Measurement of current. And the resistor will be used there as what? Shunt what? Resistor. The sixth function. A resistor can be used to what? A resistor can be used to make pull up or pull up and what? Pull down. Pull up or pull down circuit. And I demonstrated to you about this pull down circuit by using 2 components, a resistor and the pushy button. But also you have DC source and ground. So if the resistor is connected with the DC source and then the push button is connected with the ground, that is pull up. Right? But if the push button is connected with the DC source while the resistor is connected with the ground, that is pull out. Are we together? And I told you this is very, pull up and pull downs are very important circuits because actually are the circuits which used to introduce digital signal within your circuit. Okay? The seventh function, what did you say? High power resistors, So it means that high power what? Resistors, are used to do what? To dissipate power. To dissipate power or electrical power in what? In form of what? Heat. And I gave you a simple example of what? An electric iron. Are we together? An electric, because within the electric iron, the part which converting electric energy into heat energy, it has high resistance. Are we together? But another simple example, or another domestic example, is electric heater. How does electric heater heat water? So do you see the coil? Have you seen the coils within the electric heater? Yes. Then number 8, we say resistors are used to do what? To terminate what? Transmission what? Transmission lines. In where? Because you have transmission lines in electric also. Transmission lines in communication system. Are we together? And I gave you a simple example that we can use a wire resistor or a wire as a resistance. Just we can use it as what? As an antenna, which can convert electromagnetic waves into what? Electrical. For the, if it is receiving what? Antenna. If you transmit it, convert electrical into electromagnetic wave. Then number 9, we said what? A resistor can be used as what? A test nodes. Where? At distribution what? At power what? High power? High power distribution what? Centers. Are we together? So you say that measurements parameter of, so let me edit this subtitle to narrow. Of fixed resistor. Jacob! Fixed resistor, we have to narrow, because if we don't narrow as a fixed linear resistor, we can also discuss some measurement parameters of non-linear. For instance, one of the measurement parameters of resistor is temperature. So temperature, that's all about in case of semester. So semester is non-linear. So let us narrow the concept. So measurement parameters of fixed linear resistor. Linear resistor. So he said that in electrical and the electronics engineering, there are two main measurement parameters. Measurement parameters of the fixed linear resistor. Of the fixed linear resistor. And these two measurement parameters, we call them, namely, the first one is called the resistance, which use symbol R. And the second one, we call it the power rating. So this is the correction of the second question in the homework. Power rating. So there's one student who did the homework and actually found more than 2 measurement parameters. And it was some of the measurement parameters, most of them are correct, but because he went and find the measurement parameters of resistance in general, right? So he said that the measurement parameter in electronics and electrical for a resistor, we call them resistance and power rating. Say resistance and power rating. So when you say resistance, it means that we can use resistance parameter to discuss about different resistors, different fixed linear resistors. When you say about power rating, this is actually we talk about the maximum power that a resistor can withstand without being blown. Are we together? Are we together? Yes. So in this workshop 4.3, or this lecture, we are going to discuss about this first measurement parameter. Then in workshop 4.4, we'll be discussing about power ratings and about other issues. Or we'll be discussing also in detail about the parameter of resistance. So let us discuss about resistance parameter. Resistance are the parameter. Say resistance. We have defined what it means of resistance in workshop 4.1, so we don't waste much of our time. So let us go straight forward. So the measurement the measurement parameter the measurement parameter of a resistor, measurement parameter of a resistor, the measurement parameter the measurement parameters of resistor are used to define the characteristics of the resistor. The measurement parameters of a resistor are used to define the characteristics of the resistor. So say the resistance or the value of resistance of the resistance, the value of the resistance, the value of the resistance the value of the resistance, the sites, the value of the resistance of the resistor, the value of the resistance of the resistor, the sites, how much opposition force that it can provide against the flow of electric current through it. So you say the value. So the value of the resistance of the resistor decide how much opposition force that it can provide against the flow of electric current through it. So for instance, listen, let me explain this point. For instance, we have a resistor 1, which resistance is 220 ohm. And they have also resistance 2, which resistance is actually 2.2 kilo ohm. So 2.2 kilo ohm is equal to 2,200 ohm. So you have resistor 1, which is resistance is 220 ohm. We have resistance 2, which resistance is 2,200 ohm. So the opposition force offered by a resistor 1, which is 220 ohm, is less than the opposition force provided by resistor 2, with a resistance of 2,200 ohm. Why? Because the value, 2,200 ohm is greater than 220 ohm. That's the point we're trying to make. Are we together? So the value of resistor, the value of resistance of the resistor decide about the opposition force. So when you know the resistance of the resistor, then from there, you might know that how this resistor is going to affect the circuit. Are we together? So you say that a resistor that has large value, or a resistor that has high resistance value, will have or will provide high opposition force, high opposition force against the flow. So this is number one, against the flow of electric current. So a resistor that has high value of resistance will provide high opposition force against the flow of what? Of current. So what does it mean? Listen. So here we have high resistance. Listen, let me just use this simple language for you to remember. High resistance. So high resistance, this one needs what? Or our so high resistance value. So here we have high resistance value. High resistance value. This one is good. High resistance value will provide high opposition against what? Against the flow of current. High opposition force against the flow of what? Of current. But also this high opposition force will cause small amount of current, that will flow through what? Through it. So high resistance value cause high opposition force against the flow of what? Of electric current through it, right? But if there is a high opposition force against the flow of electric current, I mean the amount of current which will be passing through that resistor will be less. Are we together? Are we together? Is it clear? Good. The second sentence is this one. We say that a resistor that has smaller resistance value will provide low low opposition force against a flow of electric current. Against the flow of electric current. Our motto is mind and the hand. So we say that small resistance value, this one will imply what? Low opposition what? Low opposition force against the flow 40 against the current. And this one will imply what? A large amount of 40 of current flow. So if resistance of the resistor is smaller, large amount of current will be allowed to pass. Are you together? Yes, so that's how, those are the key points that you have. I have to remind you because I know that if you know them. Theoretically, resistors have different values. But so theoretically, resistors have different values. Means that theoretically, say theoretically. So theoretically, a resistor can have any value of resistance, different values of what? Of resistance. So theoretical resistors have different values of what? Of resistance. What does it mean? It means that, for instance, yourself, you can do a calculation. You say, around here, I just need 24.5 ohm. This is a value. Right? Or maybe you say that you did your calculation and then you come up that R3 will be having 110.6 ohm. So these are theoretical values. So it means that when you're dealing with resistance of the resistor theoretically, you don't bother about what a value. Are we together? So theoretically we say that theoretical resistors have different values of what? Of resistance. But practically, we don't make resistors of all values. This is number one. Let us go number two. Practically, resistors are not made. So resistors are not made or available in all values are theoretical values. But there are only few standard resistors. Standard resistor. So practically, say practically. Practically, theoretically, you say that all mankind have equal rights and equal power, something like that. All mankind have equality rights, but practically it's not true. Do you agree with me? Eh? Practically it's not true. It's not true. Okay, so practically, we say resistors are not made or resistors are not available in all values are theoretical values, but there are only few standard resistors. Few standard resistors. So theoretically, when you're doing calculations, maybe you're doing some calculations to evaluate, just to calculate the value of resistor. Maybe you design an amplifier, or maybe you design maybe a linear power supply, or for instance, you're designing maybe you're designing a differentiator, or you're designing an integrator, or maybe you're designing a differentiator, or you're designing maybe a stable multivibrator or stable multivibrator. So in those cases, you might calculate and get any value of resistor. But practically, we cannot manufacture resistors of all values, right? So the industry are actual that manufacture resistors of some standard values, but also those some standard values cover about the other values which are exclusive. And I will teach you that how do they cover. Are we together? So it means that resistors are made in terms of standard values. Standard. So bear that in your mind. Which are most used in practical electronics engineering. Electronics and the electrical engineering. So in practical electronics and electrical engineering. So these are the practical resistors now. So if that's the case, do you have any question at that point? Do you have any question about what you've covered? No question. For online, don't hesitate to ask the questions in the comment section. So if that's the case, ladies and gentlemen, let me introduce to you a concept that we call the standard values or standard resistors. Standard resistors. Say standard resistors. I will give you some examples of those standard resistors, and then we will draw the table that presents some standard resistors of the particular values of tolerance. We know that the resistors also have another parameter which is called tolerance, which we will not discuss it today. We'll discuss in the next workshop because it's a very important parameter. And it's one of the parameters also give us another wide range of values of resistance. Are we together? So if that's the case, ladies and gentlemen, let me introduce to you another concept called standard resistor. Standard. When you say standard resistor, for instance, in calculation you can say that you can have a resistor that is 1 ohm, the other one resistor of 2 ohm, the other ones can have resistor of 3 ohm, then you can have a resistor of what? Theoretically, of 4 ohm, can have a resistor which has resistance is what? 5 ohm, etc., etc. This is what you might think, right? Or maybe you can have a resistor of what? A resistor of 5.5 ohm, etc., 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 etc. This is what you might think theoretically. Theoretically, it's okay, but when it comes to practical, if you will be looking for a resistance of 1 ohm, you will get 2 ohm, you will get, but 3 ohms is not there, 4 ohms is not there, and even 5.5 ohms is not there. Okay? So there are some special standard resistors which actually satisfy the needs of all technicians in the world and the needs of all the engineers in the world. So don't tell us that the standard resistors are not satisfying you. Standard resistors. So let me give you some few examples. Some examples of standard resistors are, so let us start in terms of 40, in terms of in ohm. So in the ohm, simply in this way. So let me just introduce some few examples of 40 of standard resistors with a resistance of in terms of ohms. So for this case, the first resistor, first standard resistor, is the resistor with 0 ohm. Say 0 ohm. 0. We have a standard resistor which is 0 ohm. The second standard resistor is a resistor which has 1 ohm. Say 1 ohm. Say 1 ohm. Also, you have another standard resistor which is 10 ohm. You have also another standard resistor which is 22 ohm. We have also another standard resistor which is 47 ohm. We have also another standard resistor which is 100 ohm. We have also another standard resistor which is 150 ohm. We have also another standard resistor which is 200 ohm. We have also another standard resistor which is 220 ohm. We have also another standard resistor which is 240 ohm. We have also another standard resistor which is 510 ohm. We also have standard resistor which is 680 ohm. So those are the few examples of standard resistors in ohms. Listen. So good news, you have a standard resistor of 0 ohm. Okay? And also you have a resistor of 1 ohm, that's fine. But from 1 ohm, we don't have any standard resistor between 1 and 10. The next standard resistor is 10 ohm. Are you together? So the question comes now. What if in your calculation, you compute that the resistance that's required to be connected there, it's 60.5. So when you calculate and compute and then you find that it's 6.5, you know that actually there's no any resistor of 6.5. Or from today at the end, until we end this workshop, you'll know that this does not exist in standard resistor. Are we together? Then you have a gap between 10 ohm and 2240. Okay? What if in a calculation, yes, we computed and you find the resistance should be 18 ohm. So 18 ohm is in between 10 and 20. Are we together? Next is what? 47. Next is what? 100. Then 150. Then 200 ohm. 220. 240. 510. 608 ohm. So that is in case of 40, these are few examples of standard resistor in ohm. Then let us see some few examples of resistors in terms of 40 kilo ohm. Kilo ohm. Are we together? Some examples of standard resistance. We have 1 kilo ohm, then we have 2 kilo ohm, then we have 2.2 kilo ohm, then we have 3.3 kilo ohm, then we have 4.7 kilo ohm, we have 5.1 kilo ohm, we have 6.8 kilo ohm, we have 8.2 kilo ohm, we have 10 kilo ohm. After 10 kilo ohm, we have another example that is 20 kilo ohm. Then you have 33 kilo ohm. Then you have 39 kilo ohm. Then you have 47 kilo ohm. Then you have 51 kilo ohm. Then you have 68 kilo ohm. Then you have 100 kilo ohm. Then you have 220 kilo ohm. Then you have 300 kilo ohm. Then you have 470 kilo ohm. Then you have 680 kilo ohm. Okay? Just to check them because we have so many standard resistors, and you as a technician or engineer, you have to bear in your mind during your design or your implementation, you have always to say that, okay, so here I think the right resistor, I have to take a standard resistor of this value. Are we together? So you have to bear it in your mind. Then Roman 2 or number 3, let us see some standard resistors in terms of mega ohm. Mega ohm. So mega ohms, we just write a capital M, and then write this. So for mega ohm, there is 1 mega ohm. So this is not all, etc., etc., etc. Then you have 2 mega ohm. Then you have 10 mega ohm, etc., etc., etc. So these are the, so you can find that in terms of 10 mega ohm, between 2 mega ohm and 10 mega ohm, we don't have any standard resistor in between. Okay? So listen. Can you examine about these resistors and these resistors and then say that how do they relate? Examine the resistors, the standard resistors in terms of ohm. How do these resistors relate with these resistors in kilo ohm? Do they relate? The answer is yes, they do relate. How do they relate? Well, see here. Here we have 1 ohm. 1 what? 1 what? But here we have 10 ohms. So 10 ohms is actually 1, and then you add the 0. Okay? Eh? So here we have 2 digits, 1 digit. So again, because we have 1, the second resistor for that value, or for the corresponding value, will be 2 digits. The third one will be 3 digits. The other ones will be 4 digits. Continue. That's how you can memorize and how you can understand this concept. Okay? Then afterwards we have what? After 10 ohm, we have 100 OT. 100 ohm. Are we together? Yes. Then we have what again? So 100 ohms, then we go. Here we have 1 kilo ohm. 1 kilo ohm is equal to how many ohms? 1000 OT. Oh. So you see that 0 is incrementing. First digit, 2 digits, 3 digits, 4 digits. So you have to examine this relationship. This is the way even myself I used to keep these values in my brain. One of, I'm not claiming, but actually I'm trying to see, because they have relationship, and some of them they have the same number, but just see they add up to 0. Okay? This is all about 21. But we have 22 here. Say 22. We have 22 ohms, is it? Huh? The next one, the corresponding is what? After 22, next is what? This one, 220. 220 ohms. 3 digits, right? After that, the next one is what? 2200, which is 2.2 kilo ohm. Do you have 2.2 kilo ohm? Yes, this one. Okay? 2.2 kilo ohm corresponds to 2200 ohm. Class, are we together? If we still continue with this one, here we have 1 kilo ohm, right? The next one is what? We add another 0. 0. So this there are 3, now there are 4. So this 10,000 ohm is equal to how many kilo ohm? 10 kilo ohm. And you see that 10 kilo ohm is a standard what? Is a standard resistor. Are we together, Kamanzi? Is it interesting? Yeah. Then we add another 0 in 10, right? In 1. So you have 1, 0, 0, 0, 0, 0. Right? Then we put what? Ohm. 100,000 ohm is equal to how many kilo ohm? 100 kilo ohm. Where is 100 kilo ohm? This one. Right? Then we add another 0. 1, 0, 0, 0, 0, then 6. This makes what? 1 million ohm. 1 million ohms is equal to how many mega ohm? 1 mega ohm. And where is it? You see? So, for you to remember about resistance, if you are serious, it's simple, but you have to practice. Right? Are we together? Hey. But also we can add another 0. If we add another 0, we have what? 10 million ohm. Correspond to how many mega ohm? 10 mega ohm. Where is it? This one. Are we together? Yes. So then let us continue. We came with 22. 22, we added 220. We added 2.2K, which is 2,200 kilo ohm, right? After 2,000, we have 2,200 ohms. We have to add another 0. Right? If you add another 0, we are going to have 22,000 ohms. 22,000 ohms correspond to how many, is equal to how many kilo ohm? 22 kilo ohm. Do we have 22 kilo ohm? We did not just include there. But 22 kilo ohms is there. It's a standard resistor. 22 kilo ohm is a standard resistor. And next thing we have to add is 0. 22,000 ohm. So 220 220,000 ohm. Corresponding to how many kilo ohm? 220. We have it. This one. Right? And then you go and next is what? 22,004,05. This is what? 2,002,000 ohm. Right? This one. This is 2 million. What are you saying? 2,200,000 ohm. Correspond to what? 2.2 mega ohm. Are we together? That's the principle. Then we come to another one. Another one is what? 47. Say 47. That's why I told you that this class is very important. Because you learn how can you organize standard resistors in your mind. 40. So the number that you have to remember is 47 ohm. Right? The number that you have to remember is 1 ohm. The number that because you know, if you have 1 ohm, you'll have 10 ohm, you'll have 100 ohm, you'll have 40, 1 kilo ohm, 10 kilo ohm, 100 kilo ohm, then 1 mega ohm, etc., etc., etc. Right? For 22, you have just remember 22. You may not keep all of this information. So, okay, if you have 22, the next one is what? We say that it's 220. And then after 220, the next one is what? We add 0. Right? 2.2 kilo ohm. And then the next one is what? 22 kilo ohm. The next one is what? 220 kilo ohm. The next one is what? 2.2 mega ohm. Are we together? Yes. I know that this is the new concept to you. So 47. The next one is what? 470 ohm, right? In the examples, do you have 470 ohm? So this is concept of standard resistor. Class, do we have 470? No, we have 470 ohm. 470. Wait, I just skipped it. 470 ohm, but it is there. It's a standard resistor. Okay? Next is what? 4,700 ohm. Right? 4,700 ohms correspond to how many kilo ohm? 4.7 OT. Do we have it? This one. Okay, come on. This simplify life, eh? You like it, eh? Then next is what? 47000. So this is what? 47,000 ohm. Correspond to how many kilo ohm? 47 kilo ohm. Then next is what? 47,000. So 470,000 ohm. Correspond to how many kilo ohm? 470 kilo. Do we have it? Do we have it? This one. So from there you enjoy life. And then we say that, okay, I'm not sure that if there is mega ohms of that one, so I'm not sure. The next number is what, class? The next number is 300. I don't know if you have 30 ohm. I don't know. I don't know if you have a resistance of 30 ohm. I don't know. I'm not sure. Okay? But 300 ohm, I'm sure. 300 ohm. Because you have 3 kilo ohm. We have 3 kilo ohm, I'm not sure. We have 30 kilo ohm, I'm not sure. Let me just write what I'm sure. We have 33 ohm. Next is what? 303. 30. Right? Next is what? 3003 what? 300 ohm. Right? Which is 3.3 kilo ohm. Do you have 3.3 kilo ohm? Yes. Right? Remember that these are the sum examples. It's not that all the examples. No. These are the sum. So in case that we write something we don't find in the examples, it means actually not include. And next is what? 33,000. Correspond to how many kilo ohm? 33 kilo ohm. Do you have it? Okay? The next is what? 330 ohm. 330 what? Ohm. Make what? So correspond to how many kilo ohm? 330 kilo ohm. Right? Do we have it? We did not include in this exam, but it is there. Isa is Isarin. Isa is what? Yes, Isa is enjoying this concert when he is on bail. So if that the case, I ask you to copy, and once you have copied, I will give you one of the table, which you call it the standard resistors. I want to clean the whole blackboard so that I can draw that table. So that's what I'm trying to give you some time to copy so we can clean the entire blackboard. In case you are done, you can just say. Are you done? Huh? Is it okay? Oh, because you have understood, so you can write yourself. Number 4.31, the table of some standard resistors with tolerance value tolerance values of plus or minus 5. So stop writing, stop drawing, just examine this table that you are going to draw because it could help you. journey of the resistors. So these are the resistor values. The table of some of values of resistance. I think that let me write. The table of resistance values with tolerance of plus minus 5. Plus or minus 5. So look, hello. So this one is 1.20 ohm. So let me just put this way. So everything here is in ohm, and here the everything is in ohm. Everything is in ohm. Here it is kilo ohm. Here it is kilo ohm. Here it is kilo ohm. And here it is mega ohm. So look, we start with resistance of 1.20. Here you're going to have 10. 10.20.0. Or just 10 itself. Here you're going to have 40. You forgot the principle. This is 1 ohm. The next is what? Next is what? Next is what? A? Pardon? 1,000, while it is already in kilo ohm. 1. Here, next is what? 10. This one next is what? This means what? Then we go, the next external resistor is 1.1. Say 1.1. This is 11. This is 110. This is 1.1. This is 11 kilo ohm. This is 110. And this is 1.1 mega. We come 1.2, the next one is 12. Next one is 120. Next one is 1.2, okay. Here it is 12K. $12K. Here we have 120. Here we have 1.2 million. $1.20 plus 1.20. Oh. $1.3. 13. 130. 1.3K. Then you have 13. You have 130 kilo. You have 1.3 kilo. This is 14. Eh? $1.5, 15, 150, 1.5, 15, 150, 1.5 megawatt. So in this table you can see the trend that the important number is the smallest one. Separating. You could see that the smallest number is 1, right? Eh? The next is 10. Oh. The next is 100 ohm. Then 1 kilo, 10 kilo, 100 kilo, 1 mega ohm. That's the simple way for you to remember about the available standard resistors. So the same process that will be used up to 1.5. So 1.5 ohm, 15 ohm, 150 ohm, 1.5 kilo ohm, 15 kilo ohm, 150 kilo ohm, and then you have what? 1.5 megawatt. Mega ohm. Next is 1.6. This is 16, 160. 1.6. Then 160, then 1.6. So from 1.6, the next number usually we used to have said, let's say 1.7, but 1.7 is not there. Okay? So the next standard resistor, it's 1.8. Remember that here we have excluded, stop writing. Remember that here we have excluded the, we have excluded the 1.7, it's not there. So it means that 1.7 is not a standard resistor at all. So you cannot find a standard resistor of 1.7, maybe 17, maybe 22, you cannot find. So 1.8, this is 18 ohm, 180 ohm, 1.8 kilo ohm, 18 kilo ohm, 180, then 1.8. So next number is 2.0, 2.2, 2.4, 2.7, 3, 3.3, 3.6, 3.9, 4.3, 4.7, 5.1, 5.6, 6.2, 6.8, 7.5, 8.2, 9.1. I will give you this table so that you can take a photo. This is the table that can help you to understand about what standard resistance. So you take a photo, a copy of it. So remember that here the next number is 2.0. So this one will be 20, will be 200, will be 2.0, to build 20, build 200, build 20, 2.0. So you have to continue up to 9.1. 9.1. But you have to be careful because you should not say that I will go in ascending order. No. So when you be drawing this table several times in your mind, then you could know. Even your color, your principle for finding the resistance by using the color code will be more efficient. Okay? So, you say that we have standard resistors for the practical activity, right? Listen, stop writing. We have standard resistors for the practical activity. Do you think that all of these standard resistors will meet our requirement directly? The answer is no. Why? Because during your design, during your computation, maybe you calculated a resistor which is 135 ohm. Are we together? Are we together? Are we together? Yes. So now we say that we still have a problem. And the problem that we have is actually about this part. The problem that we have is actually about this table. And the problem is this one. What if the value of calculated what if the value of calculated resistance of resistor, what if the value of calculated resistance of the resistor is not within a standard value. So what if the value of calculated resistance of resistor is not within the standard values? What does it mean? For instance, you have done your computation and you found that the resistance is ranging between 180 and 200 kilo ohms. So it means that between 180 kilo ohms and 200, there are a lot of resistors there. So suppose that you did your computation and you got 190 kilo ohms. So 190 is not in this table. Okay? So if it's not in that table, that's when we made a problem. What if that the value which have been given is just a value? So that's why you say, what if the value of calculated resistance of resistor is not within the standard value? So here are the solutions for this question. We're about to wind up our class. Should not worry. If this is number one, if the calculated value of resistance is, if the calculated value of resistance if the calculated value of resistance is within the standard value. So we say then estimate so if the calculated values of resistance is not within the standard value, then estimate to near by standard value of resistance of resistor. Then estimate the nearby standard value of resistance. So I taught you with these concepts in previous concept that when we've been dealing with capacitor, that sometimes if you compute, listen, when you compute the capacitance of the capacitor, then you find that the calculated values is not within the standard value. So you have to estimate, and always estimate to the higher standard value, right? So that's one of the tricks. So for instance, you've calculated the resistance of the particular system, and you found that the resistance is 8 kilo ohm. So 8 kilo ohm is between 1 kilo ohm and 10 watt. So you always estimate, you always take 10 kilo. So that's the first method. But the second method that she said we can determine the specified values. We can determine the specified value, the specific value with respect to nearby or standard value. So we can determine the specific value of resistance with respect to the standard value by connecting resistors either in series connection or parallel connection. Listen. So this second sentence is we can determine the specific value. Say specific value. Or we say that let's say specific calculated value. So you can determine the specific calculated value of resistance with respect to the standard value by arranging two or more than two standard resistor, either in one parallel in series connection, two in parallel connection. Series connection and parallel. Are we together? So sometimes we may calculate the value of resistance and find that it's 8 kilo ohm. Okay? 8 kilo. Maybe 8 kilo ohms does not have a nearby standard resistor. What are you going to do? Simple. The way that you are going to do will be determining the resistance that the calculated value of resistance, Jacob standard. We can determine it by just arranging resistors in parallel or in what? Parallel what? So that will be one of the applications of arranging resistors in parallel or in series. And when you find resistors in the motherboards, in electronics motherboards or motherboards of electronics components or electronics devices, you'll find that you will have or you can see a lot of resistors. But remember that some of them are being connected in series, some of them are being connected in parallel, or some of them they are performing another task of floating resistor that resistor can perform. Are we together? Have you finished with Trote? Have you finished? Eh? Thank you. So let us end this workshop 4.3 or lecture 4.3. It's very interesting and very conceptual. So one of the applications of of series and parallel connections of resistors is actually in order to find or to compute the desired resistance. So we say that we have series connection, and also you have parallel connection, right? Stop writing. For instance, here we have resistance 1, and here we have resistance 2. R1, R2. Then here we have, let's say, DC voltage source. Okay? So for the series connection, we know that total equivalent resistance is equal to R1 plus what? Right? Suppose R1 is 100. Right? Okay? Suppose R2 is what? 220. Oh. For instance, just let us take in that case. Okay? So to find total resistance for that circuit, it will be what? 100 ohm plus what? 220 ohm. The answer is what? 320 ohm. So 320 ohm can be obtained theoretically in calculation, but it's not a standard resistor. Okay? So how can you, if you have a calculated value, and then you have to choose one standard resistor, listen, principle is this one. RT is equal to, let's say, X1 plus X2. Are we together? If you have 2 resistors, Rx is equal to x1 plus x2. Just I want to explain this concept mathematically. Okay? Maybe in your calculation, you have computed. Good luck now, you are good luck. You have computed it is 405 ohm, which is not UT standard. Which is not UT, the value of a standard resistor. Standard. Are we together? You do your calculation, and then you come up that I need R1, which resistance is 405 ohm. Once you go in an electronic shop, you'll never find it. Okay? But how can you formulate, or how can you have it? It's simple. If I take one standard resistor and add with another one, I might get the desired. For instance, for this case, if you take what? 470. This is standard. Right? This is what? And 470 plus what? 470 is large, is much, Class, I'm talking to you. Let's say we take 330. Are we together? 330. How much should I add to get 405? 35. 75. But 75 is a standard resistor? No. What the nearby standard resistor of 75? You are checking. The nearby is 100. This is standard resistor, and this is standard resistor. But now you can get a certain number. For instance, if you add, you get 430. 430, which is not yet a standard resistor. So for this case, means that you could take standard resistor and connect them in series. You get a new value, and in some cases, or most cases, this new value is your base. This new value, or in most cases, used to be outside the standard. So it means that it's not a resistor. It's a resistor, but it's not OT. There's no any standard resistor which has the standard resistor of 405. Are we together? So it means series connection can give you other values which even are not in what? In the standard value table. Also power connection the same story. Are we together? So for power connection, you have to wind up. For instance, that if you want just to connect this one in parallel, so let's say that here we can have another one, and this one is what? Is 200 ohm. So this is R3, this is 200 ohm. So for power connection, what do we say? We say that 1 over a total is equal to 1 over a 1 plus 1 over a 2. Hopefully you remember this one. For instance, if you take the 200, these are the two which are in parallel. Oh, this formula can be written as what? R total is equal to what? R2, R1 plus R2, then what? Resource. You know that? And if you don't know this one, you have to ignore it. So for power connection for this case, still be what? 1 over R total is equal to 1 over 200 plus 1 over 220. Once you compute there, you have to reciprocate. Faridi, you have to what? Reciprocate. So our total will be a certain value, which might not be a standard value. So that's how you can use the concepts of estimating the nearby standard resistor, or you may use the concepts of series and parity. Series and parity. Class, have you understood the concept I'm teaching you? Means series, from today you have to know series connection of resistor and parallel connection of resistor give us some other values which in most cases are calculated in value. We can calculate those values because they are different, but they are not standard, right? But in that series configuration or connection, we'll be connecting 2 or 3 standard resistor which exist. But if you take that standard resistor plus the other ones, the value, the total or the equivalent resistance might not be the value or the standard value of what resistor. But it might be what the value that you've got in calculation. And that's what I told you that. If you calculate, let's say, your resistance is 220 ohm. You say it's equal. You want maybe to connect them in series, right? You choose one standard resistor nearby this one, right? For instance, for instance, let's say 200 ohm. And as the other ones, you don't know. So you can make X the subject. Are we together? You can make X what? But remember that X, its value should be standard value. Because we connect is practically we connect the standard resistors in series or in what in parallel. We don't just do like in theoretical that we don't care that R1 is just a particular value, so it's not what there's a resistance which is not a standard value of resistor or resistance. So that's the case. Class, are we together? Is it clear? Is it clear? So I would like to see you that you are using these concepts when we're designing or implementing different circuits. So you have to think that our calculated value is this one. You should not try to estimate. Try to think how you can take 2 or 3 standard resistors and connect them either in series or what? Class, are we together? Is it clear? Do you have any question about what you have learned? Yesterday or in previous workshop, I did not teach you about how to design an antenna. Design an antenna, actually, it's a subject. It's not even a mode. It's another story and a great story. There's a lot of mathematical equations. There's a lot of techniques which are used to design, for example, dish antenna. For example, a dude antenna. For example, monopole antenna or dipole antenna. That's another story. But for myself, I've tried to give you a simple example where that we are using a resistor as a termination or terminator of the transmission line. Another question? Robin, do you have a question? Joseph Jacob, do you have a question? Have you understood? But by a lot of energy. Farid, did you understand? Have you understood? Sure. Have you understood series and parallel connection? Huh? So the homework today is, I'm going to talk it verbal. So the homework today is this one. Homework 4.3. So arrange 2 different resistors in series and the parallel, then compute its total resistance. So repeat this process 7 times. What does it mean? Listen, the homework is simple. Just to choose any 2 different standard resistors, connect them in series and parallel, Then calculate total resistance in series and total resistance in what? In parallel. That will be the first experiment or the first task. Then do 7 times with other different 2 resistors. Are we together? For instance, I say that I want to use 100 ohm and 1 kilo ohm. I connect them in series, I calculate the total resistance. And I connect them in parallel, I calculate the total. That is task number 1. Task number 2, I might take maybe 220 and 330. Connect them in OT, 220 ohms and 320 and 30 ohms. And connect them in series and OT parallel. Calculate OT, total resistance in series and total resistance in OT. Are we together? The aim of that task of this homework is actual to train your mind that series connection and parallel connections has a great contribution in relation with standard resistors when you are designing your circuit. Are we together? So that's the theme. Because if you add, once you get the response, for example, the total resistance, you have to check it. Is it a standard resistor or not a standard resistor? Are we together? Are we together? But remember that you are using 2 different OT. Because if you use the same resistor, for instance, if you use 1 kilo ohm resistor plus 1 kilo ohm resistance in series, you get 2 kilo ohm resistor, which is standard. But if you take 1 kilo ohm resistor plus 2 kilo ohm resistor, you get 3 kilo ohm resistor, which is not standard. So it means that tonight and today and even during the weekends, just think about standard resistance. Are we together? So for online students, in case you have any questions about what we've covered today, don't hesitate to ask in the comment section. But again, I believe that you've been interested and you enjoyed our contents. You ask yourself the questions how you can access the previous contents and even the nearby or the future contents. For the future contents and also previous contents, we ask you to subscribe into our official YouTube channel so you'll receive notification whenever we publish a video. We'll be trying our level best to publish at least 1 video in a week. So be connected and stay connected and be a part of this learning and special online learning institutions which actually we are trying our level best to spread the knowledge of electronics into our entire country of Tanzania. So, but remember also to subscribe. Once you subscribe, you receive notification. But remember also to share these contents with your friends, with other students, with other diploma students in electronics, with other students in just who are doing bachelor degree in electrical. These informations are very important for them. So if that's the case, I would like to say this is the end of workshop 4.3. I invite you to join me in workshop 4.4, where that we are going to discuss about another parameter, another measured parameters of resistor, but also discuss about the color coding and how we can deal with it. But remember that all of this information that we are learning, we are going to do for their simulation, and also we are going to deal with their practical implementation. This is Mwl Olenjolai. Thank you very much. May God bless you. I'm very happy to have you today, and I'm expecting to meet you in the next workshop. Bye-bye.